I am Hannah Braun. I am an assistant staff historian. No, that's okay. I'm an assistant staff historian with the Colorado Department of Transportation at the Denver headquarters office. My duties primarily revolve around environmental regulatory compliance, which sounds thrilling, but it's actually much more exciting than that. My job involves looking at historic resources along our highway corridors and documenting and researching those resources that might be affected by our transportation projects across the state. So I get to travel all over the state, see a lot of really fascinating parts of our history, and share that kind of information with you guys. So we're going to get started, and obviously the subject today is the Eisenhower-Johnson Memorial Tunnels, which I'm sure many of you are very familiar with. How many of you have driven through them just this week? A lot of you. Yeah. They're a very, very iconic piece of our interstate system. What you might not know, however, is that there's a pretty big backstory for how those tunnels even got there in the first place. And it's a story of how the early roads in Colorado developed, how our state highway system was formed, and the arrival of the interstate highway system across the nation. So I'm going to try to use the technology. So it's a little hard to see up there, but that map is a Colorado highway map from 1916. It looks like there's a lot of roads on that map, but none of them are interstates, and most of them are not what we would think of today as a road. None of them were paved. All of them were dirt, and most of them were actually wagon trails, stagecoach routes, toll roads from the mining industry. So they had a life before the advent of the automobile, and then over time, they were improved for automobile use. The process of turning our nation's early dirt roads into automobile roads was a long one, and it actually got started with bicyclists, of all things. So if you've ever seen a bicycle from the 1800s, they had no shocks. Some of them had wooden wheels. They were not very comfortable. And if you can imagine driving on like a brick or cobblestone road with your bicycle, it wasn't really a very pleasant riding experience. So bicyclists were actually the first to advocate for better roads and improved road surfaces. The League of American Wheelmen was founded in 1880, and they, in turn, founded the Good Roads movement shortly thereafter. After 1900, as the automobile began gaining popularity, automobile drivers kind of co-opted the Good Roads movement from the bicyclists, and they started forming all of these automobile clubs in favor of promoting automobiling as a recreational hobby, but also advocating for improved road conditions. The American Automobile Association was founded in 1902, so they were one of the early automotive clubs that was advocating for better roads. In 1909, the state of Colorado formed its first state highway commission. It was made up of only 3 men, and they were responsible for managing all of the roads in the state of Colorado. The first state highway maps were produced starting in 1912 that showed primary and secondary roads, all of them dirt, most of them not drivable in an automobile. In 1916, the nation passed the first Federal Highway Act. Congress made available funds at the federal level for each state to use in improving its local highways. In Colorado, we identified 6 federal aid projects to improve some of our existing road systems in the state. In 1917, Congress passed the second Federal Highway Act, which appropriated even more money for the improvement of state roads. That same year, 1917, Colorado formed a state highway department, now with paid employees who could actually conduct the work on our road systems. In 1918, we paved the first stretch of road in the state of Colorado. It was a part of Santa Fe Drive, south of the town of Denver. That was the first piece of road we had, 1918, that was paved. In the 1920s, in order to guide travelers on our state roads, we started erecting road markers and signage, like this example here, so that travelers knew how far to their next destination. These are some examples of the Colorado Highways magazine. This was the magazine of the State Highway Department from 1918 through the 1930s. It highlighted a lot of our federal aid projects across the state. It also talked about construction and maintenance methods that we were using on our early highways. And as you can see from the pictures, it highlighted the rustic quality of our early roads and served as a kind of a boosterism device to encourage people to support asking Congress for more money to improve our road systems. These are a couple examples of early roads in 1922. The one on the left is State Highway 30 in Lincoln County. It was a sand and clay surfacing on a dirt road between Lyman and Genoa. This photo was actually taken right after a heavy rainstorm. And this is a prime example of why the state wanted to get a jump start on paving as many roads as we could. You get a big thunderstorm out on the plains and the road could be completely washed away the next day. The photo on the right is from Castilla County with Mount Blanca in the distance, and that obviously also a dirt road at that time. At the same time that across the nation we were talking about improving roads and figuring out how to appropriate money to pave those roads, there was also this national trend toward wanting to build a transcontinental automobile road. In the 1800s, there was this big push to build a transcontinental railroad across the U.S. We finished the first railroad in 1869. So now this was the next phase. The new technology was the automobile. And what better way to unite the country than to build a road all the way across it? Promoters of the Transcontinental Highway said that it would help tourism, it would increase commerce across the United States and economic development in the states through which it passed. In support of this idea of the Transcontinental Road, there were a lot of automobile enthusiasts who actually drove cross-country across the U.S. in their little Model Ts over existing roads, if there were some, and sometimes they just drove across the prairie where there was no road, taking photographs and doing interviews with reporters, kind of trying to promote this notion of why we needed a transcontinental road. Probably most of you are familiar with the Lincoln Highway. That was the most famous transcontinental road that we ended up building starting in the 19-teens. Today, most of its alignment is followed by Interstate 80 across the U.S. The Lincoln Highway actually never went through Colorado. They had a little spur that dipped south into Denver, but it was later dropped from actual construction. So Colorado felt a little gypped. We didn't get the Lincoln Highway, but we did actually have a few other transcontinental routes. One of the most famous was the Pikes Peak Ocean-to-Ocean Highway. You can see the map of the route up there and a promotional poster. This was built during the 19-teens and 20s. It ran from New York through, to Los Angeles and passed through Colorado Springs. Most of the alignment of the Pikes Peak Ocean-to-Ocean is now U.S. Highway 24. We also constructed the Victory Highway, which ran over 3,000 miles between Atlantic City, New Jersey, and San Francisco, and it passed through Denver. It's now U.S. Highway 40. The Rainbow Route ran from Ocean City, Maryland to Sacramento. It's now U.S. Highway 50, and it also follows part of the Santa Fe Trail through southeastern Colorado. The Roosevelt Highway, now known as U.S. Highway 6, ran from Massachusetts to California. And just to shake it up a little bit, we also built the Great North and South Highway, which Transcontinental the opposite way. It's now old US Highway 85, paralleled by much of Interstate 25. So by the 1930s, we had a couple of primary east-west highways in Colorado. They followed the alignments of what's now US Highway 6 and US Highway 40. The top two pictures with the snow are Loveland Pass on US 6, and the bottom one is a photo of Berthoud Pass on US 40. Obviously, as you can see, these routes were pretty rustic in the 1930s and could be treacherous during the winter months. Loveland Pass receives an annual snowfall of 26 feet, so trying to keep Loveland Pass open in the winter was quite a challenge in the 1930s. So some people started talking and they thought, you know, if we could build a tunnel through the Continental Divide, through the mountains, maybe that would improve driving conditions and we could manage to keep these roads open throughout the winter, or at least for part of the winter. And so the State Highway Department began surveying for a tunnel location near Loveland Pass as early as 1932. Beginning in 1941 through 1943, the Highway Department drilled a 5,000-foot pilot bore or exploratory tunnel to assess the geologic conditions near Loveland Pass. This location was about 3 miles south and a few hundred feet higher than the location of the future Straight Creek Tunnel, today's Eisenhower-Johnson Memorial Tunnels. These photos show the exterior and a shot inside of that pilot bore. Conditions in the pilot bore were not that great. There was a lot of broken and fractured rock, excessive water, a fault line. It wasn't really great rock conditions for building a tunnel. The Public Roads Administration reviewed some options for this tunnel. They considered either building a one-way route through the mountains or a two-way tunnel. Their conclusion was that a one-way tunnel would be too dangerous. Couldn't see the head-on cars. That was a good point. And then interestingly, they decided that a two-way tunnel just wasn't justified because there wasn't enough traffic. Kind of wonder, you know, if they were living today, what they would say about I-70. The Highway Advisory Board ended up allocating $1 million to complete the first 2,000 feet of a tunnel. They advertised the project in 1947. They only received one bid, and that firm said they could do it for $10 million, 10 times the allocated amount. So the State Highway Department thought about it, and they decided it just wasn't feasible. It was just going to be too expensive. They still weren't really sure if there was going to be enough traffic that we needed to build this tunnel. So at the end of 1947, they shelved the tunnel project, and they reallocated the money to make improvements on the existing alignment of US Highway 6 over Loveland Pass. But you know, things kind of changed after World War II. Our economy and tourism industry started booming, and it became apparent that a connection between Colorado's development and our highway system was really important to the future development of the state. In particular, we had the ski industry, which just exploded after World War II, particularly by the 1960s. Skiing had actually started in the 19th century. There were a lot of miners and mail carriers that used skis to get around in the wintertime. By the turn of the century, it had kind of morphed into more of a recreational sport. Some early ski areas were opened even before World War II. People were skiing at Loveland, Winter Park, and Arapahoe Basin. Ski Cooper opened in 1941 as a training base for the 10th Mountain Division at Camp Hale. After World War II, a lot of those soldiers from the 10th Mountain Division came back to Colorado and were instrumental in establishing many of our well-known ski areas and improving the existing ones. Some of those post-war ski areas included Breckenridge, Vail, and Keystone. all of these people coming to Colorado to ski put a lot more pressure on our road system, especially when you think of Denver being on the opposite side of the Continental Divide from us here today. How are these people supposed to safely get across the mountains, especially in the winter? Especially because in the 1940s, many of our roads still weren't paved. We were in a process of doing it, but there was only so much money. So the tunnel came back up. The 1950s marked an era of tunnel fever in Colorado. In 1953, the Colorado General Assembly directed the State Highway Commission to develop plans and a cost estimate for a toll tunnel through the Continental Divide. In 1954 through 1956, the Highway Department sponsored a number of tunnel studies with firms from New York. They evaluated 4 different routes, including Straight Creek, which is the current location of the tunnel, Loveland Pass on US 6, Devil's Thumb near Nederland, and Jones Pass, which is near Berthoud Pass off US Highway 40. Kind of concurrent with this revival of the tunnel idea in Colorado was the development of the nation's interstate highway system. The idea for the system actually started during World War II. General Eisenhower was in Germany, toured the Autobahn, saw how effectively the Germans were able to move supplies and troops across their country during the war. And he became convinced that having a connected highway system was critical to national security, and he wanted to bring the idea of the Autobahn to America. He wasn't the only one thinking about this. In 1941, President Franklin Delano Roosevelt appointed a committee to study the idea of a National Expressway. A series of federal acts in 1944, 52, and 54 proposed and selected some routes for an interstate highway system, but there wasn't any funding at that time. It actually wasn't until the Federal Highway Act of 1956 that we got our interstate highway system. This act established design standards and a system for distributing federal funds to the states to build the interstate. The interstate system would ultimately encompass 42,000 miles of primary highways, including 62 superhighways and 261 beltways. In Colorado, as part of the selection process for where to put the interstate, we found 3 possible interstate routes. All of them were ultimately built. One being I-25 from Cheyenne, Wyoming, all the way down to Raton Pass at the New Mexico border. Interstate 76 from Denver to Nebraska. And I-70 from east of Denver all the way to the Kansas state line. Incidentally, they did not select a route between Denver and the Utah border. Governor Edwin Johnson, who is previously a Colorado senator, and Eugene Milken lobbied for an interstate connection through Colorado's mountains. Johnson was adamant that it was really important to make sure that the entire state was connected east to west, and promoted this notion of a complete interstate highway system through the state, even though the Department of Highways was still not really sure it was necessary or that we could manage to fund it. It actually wasn't until 1957 that the Bureau of Public Roads approved the final link of I-70 from Denver to Utah. The construction of the interstate highway system kind of gave additional impetus to the tunnel fever and where we were going to stick this tunnel through the Continental Divide. In 1959, the Colorado Department of Highways hired E. Lionel Pablo Engineering of New York City to study interstate highway connections west of Denver between Empire Junction and Dot Cerro. This map shows some of the different routes that they were considering. They evaluated 8 routes in all, including some of the previously evaluated tunnel routes. Ultimately, they recommended Straight Creek as the best option. In 1962 and 1963, the Department of Highways advertised contracts for clearing and grading approach roads to the new tunnel location. And in 1963, they advertised a contract to build a 10-foot by 10-foot, 8,000-foot-long Pioneer bore through Mount Trelease. This bore revealed, surprise, many of the same geological and engineering challenges that earlier teams had discovered near the Loveland Pass location in the 1940s. There was lots of rock movement, slide areas, runoff water, and fault lines. In the summer of 1964, the floor of this Pioneer bore actually rose 10 feet, or a tenth of a foot, in only 24 hours. 10 feet would be a lot. That would be very bad. Tenth of a foot in 24 hours. This was still substantial. The rock pushed in on the bore, and they had installed timber and metal support beams throughout the bore, and the pressure of the mountain actually broke all of those steel and timber beams. It was not a good sign of what was to come. In 1967, the Department of Highways signed a contract with Straight Creek Contractors, which was a joint venture of 4 separate companies that were going to build the tunnel. They had a low bid of $54 million. Negotiation later reduced that amount to $49 million. Just keep that in mind because we're going to revisit the cost later on. That contract was the largest that the Department of Highways had awarded to date in its approximately 60-some years of existence. The plan was ultimately to construct 2 side-by-side tunnels. One would be for eastbound traffic and the other for westbound. Once the first tunnel, the westbound or north tunnel, was built, then the Pioneer bore that they had just dug would be expanded for the southeastbound tunnel. This slide shows you a cross-section of the proposed tunnel from the 1960 Pablo engineering study. And that's the Pioneer bore. In February of 1958, workers laid track for the muck disposal, the excess rock that they were clearing out of the tunnel. And then on March 15th of 1968, they actually began construction on the North Tunnel. And that shows them dynamiting the rock in action in the winter. These images show the pilot bore for the Straight Creek Tunnel, which is the North Tunnel, in 1968. You can notice the massive buildup of ice in the tunnel there in that picture. This was due to groundwater seepage that then froze. And so every single day, the workers had to go in and clear all of that ice out before they could even begin laying their charges to dynamite. This was just one of the problems of working at an elevation of 11,000 feet in the winter. But one of the biggest setbacks that they encountered was the discovery of a fault zone in the path of the North Tunnel that they had not discovered during the pilot bore excavation. These fault lines began to slip during construction, and emergency measures had to be taken to protect the tunnels and the workers who were at risk for cave-ins and collapses. Despite everyone's best efforts, 3 men ultimately died building the South Tunnel, or building the North Tunnel, and then 4 died building the South Tunnel. Further complicating construction efforts, the boring machines that they were using didn't work as fast at such high elevations, and so their productivity started slipping, and so did the deadlines. The project stretched on a lot longer than planned. The frustration prompted one engineer to comment, "We were going by the book, but the mountain couldn't read." These shots kind of show some workers in action working in the northbound tunnel. A few more shots of the construction area at the west portal in 1968. And then the bottom photo down there with the People is a Bureau of Public Roads tour in 1968. And these are additional 1968 photos showing excavation for the South Tunnel at the West Portal area on the left. And then the right view is a bunch of miners pouring the wall plates for the tunnel. You can kind of see it starting to come together finally. On the left is a shot from the East Portal area of an inspection party that were surveying some of the geological formations in a slide area. And then on the right is a loader that serviced the jumbo drill, and they're working in an area where they encountered a lot of bad rock in the fault zone in 1969. Workers excavated the tunnel from both sides simultaneously, but they encountered quite a few problems starting in 1969. The rock pressed and squeezed, trying to reclaim the bore that the men had just dug. This caused cave-ins on the west end and mangled the steel tunnel arch and timber support beams on the east end. Trying to figure out how they were going to continue construction, in 1969 they built an experimental and costly movable 670-ton shield, which was designed to support the tunnel crown, or the top arch of the tunnel, and protect the workers. This piece of machinery actually only crept 70 feet into the tunnel before the pressure of the mountain froze its rollers, and the structure had to be dismantled piece by piece, hauled back out of the tunnel. In 1971, after a work stoppage, they came up with another idea. This was the use of multiple drifts to improve their excavation efforts. These drifts were smaller tunnels that were built alongside the main bore, and after being dug were filled with concrete. This helped stabilize the mountain so that then men and machinery could enter the main bore of the tunnel without as much risk of collapse. The Department of Highways Chief Engineer Charles Shoemate oversaw the tunnel construction from start to finish. In October of 1969, the American Highways magazine interviewed him and quoted him as saying, "It is a prodigious undertaking, about the equivalent of pushing a 5-story building through the mountain." Actually, boring the tunnels wasn't the only thing that the workers had to do in order to make a tunnel that was fully functional. They also needed a massive ventilation system. If you think about the number of cars traveling this long distance through the mountain range and the carbon monoxide emissions that we're having to deal with, it could get pretty deadly inside that tunnel really quick, and they needed a way to pump that carbon monoxide out. So engineers spent several years conducting high-altitude field surveys and lab tests in order to design a tunnel ventilation system that would work for this length and at this altitude. Ultimately, they built buildings at each tunnel portal that housed 8 massive fresh air fans and 8 exhaust fans to ventilate the tunnel. The vents were housed above the tunnel roadway and the curved heading of the tunnel. So on the left you can see a view of the east portal and east ventilation building with its big exhaust stacks in 1971 while they were still under construction. And then the right shot shows the ventilation building looking east. You can only imagine how much activity was probably happening at both portals of the tunnel. These are some shots of the work areas during 1971. One of the really inspiring stories that came out of the tunnel construction was the story of Janet Bonema. She was kind of a Jill of all trades, if you will. She was the former captain of the University of Colorado ski team. She was a rock climber, a motorcyclist, a licensed pilot. In 1970, she took the Colorado Civil Service test for an engineering technician position with the Department of Highways. The supervisor looked at her test and misread her name. There was a typo. He thought she was a James. Janet was notified via letter that he had qualified for a job at the Straight Creek Tunnel. When she called to discuss the job, the state employment office told her the offer had been for a man. Women were not allowed to work in the tunnel, and she wouldn't want to work there anyway. It wasn't safe. She wanted the job, but instead she was assigned a position doing office support work. There was a lot of opposition to women workers at the tunnel. One supervisor said that if she entered the tunnel, those workers would flat walk out of their tunnel and they'd never come back. Most of the workers came from a mining background, and a lot of them believed a common superstition in the mining community that a woman brought bad luck to a mine or a tunnel. One worker insisted, "It's a jinx. I've seen too many die after a woman was in the tunnel." Janet wasn't fazed by any of this. She actually filed a sexual discrimination lawsuit, citing the Department of Highway's refusal to allow her to conduct a job that she was clearly qualified for. She'd passed the civil service exam. She was also in better shape and more agile than a lot of the male workers. If the Department of Highways didn't let her do her job, she believed it would adversely affect her ability to get another engineering job in the future. Ultimately, her lawsuit was settled out of court, and she won the right to work in the tunnel and a financial settlement of $6,750. She entered the tunnel for the first time on November 9th, 1972. 60 workers promptly walked off the job. She re-entered the tunnel a few days later, this time dressed in coveralls, and was assigned tasks on the roof of the tunnel overlooking the men below. Either nobody cared that she had re-entered the tunnel, or they didn't even know who she was, and didn't know that she was a woman. She felt that it was her disguise. The coveralls helped. She continued to periodically enter the tunnel to record measurements, retrieve rock samples, and conduct inspections. Earlier, I mentioned the ventilation system that had to be installed for the tunnels. But there was an even cooler piece of technology, the control room. Thankfully, it doesn't look like this today. But at the time, this surveillance system was modern for the day. It included closed-circuit television network to monitor traffic passing through the tunnels. It has since been upgraded with newer computers and cameras so that a 24/7 crew can monitor traffic and quickly respond to any emergencies that might occur. These shots show the interior of the tunnel just before it opened. It had shiny prefabricated wall tiles and ceiling panels faced with porcelain enamel steel. And there was also a state-of-the-art lighting system. Project manager W.K. McLaughlin joked about the tunnel in a March 1973 Denver Post article. He said, "Up here, they call it the longest bathroom in the county," due to its antiseptic appearance. When I was driving through the tunnel on my way here, I thought, it doesn't quite look that shiny anymore, but the West Bore, or North Tunnel, was originally named the Straight Creek Tunnel, but ultimately it was dedicated as the Eisenhower Tunnel, named after our president, who had helped create the Interstate Highway system and was also pretty fond of Colorado and a promoter of the Interstate Highway system and this tunnel through the Continental Divide. The tunnel, which had been construction had began on March 15th, 1968. It was completed 5 years later on March 8th, 1973. The photo on the left shows the dedication of the Eisenhower portal with Governor John Love. The ceremony was actually held inside the tunnel. They even had a military band performance Don't know what the acoustics were like for that, but it was pretty cool. During his keynote, Governor Love said that this tunnel, as part of the interstate system, represents the most recent and possibly the most effective answer to tying East and West Colorado together and opening the way west. That same day, they opened the tunnel for traffic, and 4,666 cars drove through. As you can see, at the time it was two-way. They were still working on the south-eastbound tunnel. So it was two-way until the second tunnel was completed. Work on the south tunnel was begun on August 18th, 1975, and completed on December 21st, 1979. This tunnel was named the Edwin C. Johnson Tunnel. It was named after our past governor and senator, who had so long been a promoter both of a tunnel through the Continental Divide and also of our interstate highway system. And in case you love random facts, over 6,000 people worked on the tunnels throughout the course of its construction for both tunnels. 1 million cubic yards of material was excavated out of both bores of the tunnels. Eisenhower Tunnel completed in 1973 at a cost of $110 million. That's $1,100 per inch. Now recall, the original bid for this project was $49 million, so came out just a little bit over budget. No big deal, right? And then Johnson Tunnel completed in 1979 at a cost of $125 million. The tunnel is almost 1.7 miles long. It used to be the highest vehicular tunnel in the world. They've recently built some tunnels in China that are actually higher in elevation, but we're still the highest in the US. It's also the highest point on the interstate highway system. 11,013 feet in elevation at the east portal and 11,158 feet in elevation at the west portal. Keeping the tunnels in operation is an expensive task. The electric bill averages $70,000 per month. The tunnel does have its own power station and a reservoir and water treatment plant to supply sinks and bathrooms within the tunnel for the workers. It operates 24 hours a day, 7 days a week, 365 days a year, with 52 full-time employees. Those employees are assigned a variety of different tasks: television surveillance, emergency response, tunnel washing and sweeping. So apparently they do wash it. Still doesn't look as antiseptic as it used to, but maintaining the ventilation system, removing snow, servicing and repairing the heavy equipment stored on site, and water treatment duties. If you drive through the tunnel, you'll notice that there are sidewalks in both bores, telephone boxes, cameras, fire exits, fire hydrants and extinguishers, and carbon monoxide detectors. The tunnel also has its own fire department with fire engines. In 2016, an average of almost 34,000 vehicles passed through the tunnel each day. Total annual count for 2016 was 12.4 million vehicles. CDOT is very proud of the fact that ever since opening day, even though we've had 400 million vehicles pass through the tunnels, we have never had a single motorist fatality. There have been a few emergencies, but thankfully no one has died. It's quite a feat when you think about it. I also recently found these photos, and I love them because usually we see the tunnels while we're driving through it, but this is a really fun aerial view of the east portal. Kind of shows you how much of a mountain they were really boring through. And a little bit closer shot. I had never noticed this, but there is a road that wraps around the portal so that you can turn around and go back the other direction. So I'm going to leave that slide up there for now if you want to jot down any of those web addresses to find out more information I also have business cards on the back table, and you're welcome to email me with any other questions. But does anybody have any questions? Yeah.
I have a question. First off, I got two questions. One is the road you just showed us. Is that authorized for private vehicles to turn around if the tunnel's closed?
Yes, yeah. There's actually also a sign, if hazardous waste trucks end up missing the Loveland Pass exit, they can actually turn around so that they can go over Loveland Pass.
The other question is, could you speak about the policy of having hazmat trucks go over Loveland Pass?
Right. So, as some of you might know, hazardous waste vehicles hauling hazardous waste are not allowed through the tunnel on a general operational basis. They are required to go over Loveland Pass on US Highway 6. And the reason for that, it's just a safety concern in case there was a truck fire or something like that, operator error. They don't want any other driver's lives to be lost. And if you think about the tunnel in that enclosed space, if something happened, it could be pretty catastrophic. So hazardous waste material vehicles are required to go over the pass. When Loveland Pass is closed, they will actually close the tunnel every hour on the hour to allow hazardous waste trucks to go through the tunnel alone before the general public is allowed through the tunnel. So just a safety precaution for everyone. Yes?
I have a comment. You're talking about accidents. Years ago, I was driving a 30-year-old vehicle through the tunnel and it stopped about a third of the way in from the east bore going up toward Summit County. And the car didn't have flashers or anything else, but what took place is the car behind, when he could tell, I kept slowing down. I had gas starvation, slowing down, so every car behind me was slowing down. And the guy behind me threw his flashers on and he got out and started waving people around. And then I guess on those cameras they saw me and they came in and then a wrecker hooked me up and pulled me all the way to the other side.
That's really cool. Yeah, we did a PBS Colorado Experience special on the tunnels, and there was an engineer who was interviewed, and he mentioned an automobile fire that happened in the tunnel that the driver didn't even notice at first that his vehicle was on fire. The guys in the control room saw him. Their response time was under 6 minutes, not just to get down there to him, but actually to pull him all the way out the tunnel. So they are watching, and if you have a problem, they will pull you out safely. Yes?
Question. You mentioned that the original bid was $54 million, and then reduced to 49, which pretty much doubled. What was the original schedule thought to be?
You know, I'm not sure. I did not come across that in my research.
It was doubled as well.
Probably, yeah. They didn't anticipate having quite the problems with the mountain that they ended up at. You know, it took 5 years for that first bore. The second bore was a little better. It didn't run through the fault line, so that's why the second tunnel did not take quite as long to pull
We're
through.
going to take one more question because of the weather. We do need to let Hannah
Yeah,
get going. Thank you.
An interesting note, there was a book written by a guy who walked around the world in 4.5 years. The closest he came to death was going through Eisenhower.
And with that, I think that's fantastic.